Hello friends, today I'll discuss about transformer differential protection ABB make RET 650, that is RET 650. Before going through this video, you are requested to please go through my channel and do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Now how does the ABB make RET 650 differential current calculated? Differential current is a vectorial sum of all the individual phase current from the different sides of the protected power transformer. In case of other relay, it is nothing but the vector sum of all the phase current after the matching factor is encountered. That is HV side current is multiplied by the matching factor, and also LV side current is multiplied the matching factor, and the per unit current in terms of vector form, the sum of the per unit current in the HV side and LV side after the matching factor is accounted for differential current by phase wise. But in case of RET 650, before any differential current can be calculated, the power transformer phase shift and its transformer ratio must be accounted for. That is, for YD1 type or YD5 or YD11 type transformer, there is phase shift between HV side and LV side current, and also due to different voltage ratio between HV side and LV side, the value of the current in the HV side and LV side is not same. So this is accounted for differential current calculated. So conversion of all the current to a common reference is performed in two steps. The number one is all the current phasor are phase shifted referred to the phase reference side. Here phase reference means the HV side winding. If HV side is star connected, then the star winding is taken as the reference winding, and if LV side is star winding, then LV side winding is taken as the phase reference. But in case of DD type transformer, then HV side delta connected winding is taken as the reference connection. Number two is the current magnitudes are always referred to the first winding of the power transformer. That is, if it is a Y delta type, then the current magnitudes are LV side current magnitudes are converted to the HV side or star connected reference side. Then the differential current is calculated as a vector sum of the individual phase current. This is the philosophy for calculation of differential current in ABB make RET 650. Now the bias current. How does the ABB make RET 650 calculate the bias current? The bias current is calculated as the highest current amongst all individual winding current contribution to the total fundamental frequency differential current. All individual winding current contribution are already referred to the power transformer winding one side. That is, if it is a HV side is star connected, then all the individual winding current is converted to the star side winding or reference winding, and therefore the highest of the HV side winding is taken as the bias current. For example, if it is a YND1 type transformer and HV is Y connected, and that is why all the current are taken irrespective star connected winding or HV side winding. That is, star connected winding is taken as the reference. Therefore, the maximum of the three phase current of the star side or HV side is taken as the bias current. Again, for I bias is calculated based on the maximum current in respect of the rated current in star side. If rated star side current is I, and IHV is the maximum of all phase current in the star side or HV side, then I bias in per unit quantity is given by IHV divided by I rated current in HV side. So for calculation of differential current in phase wise, the following formula is used in RET 650. the number one in the left hand side in the equation is the phase wise differential current, that is IDL1, IDL2, IDL3 are the red phase differential current, yellow phase differential current and blue phase differential current respectively, and IL1 W1, IL2 W1, IL3 W1 is the red phase, yellow phase and blue phase current in the HV side winding respectively, and IL1, IL2, IL3 W2 are the red, yellow and blue phase current in the LV side winding respectively. And A or B two matrices are introduced for calculation of differential current. The value of the A matrix depends on the zero sequence filtering and without zero sequence filtering, and B matrix depends on the phase shift between HV side and LV side winding. So there is another factor, that is UN under UN W2 and UN W1. This is done to convert the LV side current in the common reference winding, that is HV side winding reference. UN W2 is the LV side rated voltage face to face, and UN W1 is the HV side face to face rated voltage. This is how the differential current is calculated in RET 650. IDL1, IDL2, IDL3 are the three differential current, that is for red phase, yellow phase and blue phase. All the differential current is referred to the W1 side or primary side winding, and IL1 W1, IL2 W1, IL3 W1 are the red phase, yellow phase and blue phase current in the W1 side or in the primary side, and IL1 W2, IL2 W2, IL3 W2 are the red phase, yellow phase and blue phase current in the LV side winding or W2 side. These are already discussed in the previous slide. Now the value of the matrix AB coefficient depends on the power transformer winding connection type, such as star star or star delta or delta delta. Number 2 is transformer vector group, such as YD1 or DY11 or YD11, which introduce a phase shift between HV side winding current and LV side winding. For YD1, the LV side winding lags from that of the HV side by 30 degree. For DY11, the LV side winding current leads by that of the HV side winding current by 30 degree. Number 3 is the settings for elimination of zero sequence current for the individual winding. That is, if HV side is star connected with neutral is grounded, then the zero sequence current must be eliminated for counting of the differential current, and this A matrix depends on the zero sequence current elimination. If the HV side winding is delta connected, then the value of the A matrix is different of that of the without with zero sequence elimination. During this calculation, the following rules are used. For the phase reference, the first winding with star connection is always used. That is, if the first winding is star connected, then reference winding is taken as the HV side winding or star side winding. For example, if the power transformer is YD1 type, then the HV side winding is star connected and LV side winding is delta connected. Then HV side winding, that is stars connected, is taken as the phase reference, and all the current is converted to the star side winding, and the differential current is calculated based on the common reference winding. If the power transformer is DY1 type, then the LV side winding, that is star side winding, is taken as the phase reference. In this case, the delta side winding current is converted to the common reference winding, that is star side winding, and then the differential current is calculated. If there is no star connection winding, such as if it is a DD type, DD0 or DD6 type of power transformer, then the HV side delta winding is automatically chosen as the phase reference winding. This is the inherent features of the ABB make RET 650. Now the characteristics of the RET 650 is shown in this diagram. X-axis shown the bias current or resistant current in per unit quantity, in percentage of the maximum current, phase current of the reference winding, of the rated current in the reference winding. Again the operating current or differential current shown in the y-axis, which is the percentage of the differential current taken in the reference winding in terms of the rated HV current. So between 0 to end section 1, the ID minimum setting is given due to phase mismatch of the CT or ratio error of the CT, and also some differential current present due to the tap changing of the transformer. And between end section 1 and between end section 2, a slope is given, that is K1. The lower portion is the restraining current and upper portion is the operating current, and between and above the end section 2, higher slope is given, so that higher slope K2 is given, so that it can maintain stability under through-fault condition. This is the characteristics of the differential current of the RET 650. Now how the RET 650 calculate the differential current? One example is taken for 50 MVA YN D1 132 by 33 kV transformer. Now since HV side is star connected and LV side is delta connected, and there is phase shift between HV side current and LV side current of 30 degree lag, the A matrix and B matrix is automatically relay choose, that is 1/3 of 2 1 1 1 minus 1 2 minus 1 1 1 2. That is the value of the A matrix with zero sequence filtering. And again the B matrix for phase matching due to phase shift between HV side and LV side current is shown in the equation. And UN-W2 and UN-W1, UN-W2 is 33 and UN-W1 is 132. The phasor diagram for HV side winding current and LV side winding current is shown. The left side is shown the HV side winding current, and right hand side is shown the LV side winding current. There is phase shift between HV side and LV side is and that is if HV side red phase current is at an angle of 0 degree, then LV side red phase current is at an angle of 150 degree. The reason is in the HV side the current is entered from P1 to P2 direction in the CT primary side, but in case of LV side, since it is a YN D1 type, there is a phase shift between LV side current and HV side current of 30 degree lag, but due to the current is flowing from the P2 to P1 direction, there is a further 180 degree phase shift occur in all the secondary side of the current, and that is why the LV side current is phasor is at a 150 degree leading from that of the HV side current. Similarly for yellow phase and blue phase respectively. So as per the equation, IDL1, that is differential current for red phase, is given by 1/3 of 2 into IL1 W1 minus of IL2 W1 plus IL3 W1 as per the equation above, plus 33 by 132. 33 is UN W2, that is the rated phase to phase voltage in the LV side winding, and 132 is the rated phase to phase voltage in the HV side winding, that is UN W1, into 1 by root 3 into IL1 W2 minus IL2 W2 as per the equation above. IL, that is the red phase current, and minus yellow phase current. Now for three phase balanced current, IL2 W1 plus IL3 W1, that is in the HV side sum of the three phase current is 0, so IL2, that is yellow phase current plus blue phase current, is nothing but the red phase current, so it comes as the 2 IL1 W1 minus of IL2 W1 plus IL3 W1 as minus of IL1 W1. So minus and minus comes as plus, so it is 3 of IL1 W1, and in the outside there is 1 by 3, so it comes as IL1 W1 plus 33 by 132 comes as 1 by 4th into 1 by root 3 into root 3 of IL underscore W2 at an angle of 180 degree. Now what is IL? IL is the, since it is a three phase balance supply, the all the phase current in the LV side, that is IL1 W2, IL2 W2, IL3 W2 is same, that is considered as IL, and phase shift by 120 degree apart from each phase. So IL1 W2 minus IL2 W2 comes as root 3 of IL W2 at angle phase up at an angle 180 degree. So this summation of these two vector, that is 1 by root 3 into root 3 comes as 1, and IL W2 divided by 1 by 4 which is taken in the HV side winding comes as exactly same of the IL1 W1, but in a phase apart of 180 degree, and that is why IL1 W1 plus 1 by 4 IL W2 at an angle 180 degree comes as 0. This is how the differential current for ABB make RET 650 is calculated. Similarly for red phase, yellow phase and blue phase winding, ID L2 and ID L3 comes as 0. But in actual, the differential, there is a slight differential current exists due to CT error, and also due to tap changing, different tap position in the oil dishing.